Now let us solve this problem. You have a 10-meter long potentiometer wire. So you have AB, which is 10-meter long potentiometer wire, which carries a current of I. So through this current I is flowing. So obviously there is a primary circuit which provides the current. Its EMF is E. Now a 1.018 volt standard cell is balanced at a length of 850 centimeters. So the second cell, its EMF is given as 1.018 volt, is balanced at a length of 850 centimeters. Find the potential gradient and Emax. So potential gradient, as we already discussed, potential gradient and Emax. Emax means how much maximum potential can be measured using this potentiometer. So Emax means how much is being provided by this cell. Now to find the potential gradient, as we have already discussed, potential gradient is how much the potential varies per unit length of the wire. Now here it is given, it is a 10-meter long wire. So total length is, if you convert it into centimeters, it is 10 times 100, so 1000 centimeters. Now a 1.018 volt standard cell is balanced at a length of 850 centimeters. Means what? 1.018 volt is equal to potential gradient multiplied by the balancing length. This is how the equation comes. So potential gradient is how much the potential varies per unit length multiplied by the length which it balances is equal to the EMF of the cell. So EMF of the cell is equal to potential gradient times balancing length, and the balancing length is given as 850 centimeters. So you have to find the potential gradient. It is 1.018 volt divided by 850. So potential gradient is equal to 1.018 divided by 850. So it will come something like 1.2 times 10 raised to minus 3 volt per centimeter. So for each centimeter from starting from A to B, the potential varies by 1.2 times 10 raised to minus 3. So as the length increases, the potential difference increases. For each centimeter, its change is 1.2 into 10 raised to minus 3 volt. So that is what they mean by the potential gradient. Now the second part of the question is how much is the maximum EMF which can be measured by this cell. See, the maximum EMF measured by the cell is equal to potential gradient. So Emax, that is the maximum EMF which can be measured, is equal to potential gradient multiplied by the total length of the wire. How much is the total length? That is 1000 centimeters. So Emax is equal to 1.2 times 10 raised to minus 3 multiplied by total length of the wire. If you convert it into meters, it will be, centimeters, it will be 1000 centimeters. So you have 1.2 volt. So with this particular arrangement, the maximum EMF which can be measured is equal to 1.2 times 1.2 volts. So the cell is providing you an EMF of 1.2 volt. So hope you understood. A 10-meter long potentiometer wire carries a current I. A 1.018 standard cell is balanced at 850, means 1.018 is equal to 850 times the potential gradient. From that you found the potential gradient, that is how much the potential varies per unit length of the wire. And once you know how much it varies per unit length, and if you multiply it by the total length of the wire, you will get the EMF maximum EMF which can be measured using the circuit.